Good morning, everybody. Today, actually, I'm going to start the basic understanding of electromagnetic wave and with derivation of the wave equation in free space as well as medium and different possible solution of the wave equation. And this understanding of this wave equation and different parameter associated with the electromagnetic wave, specifically electric field, magnetic field, propagation vector, and is very important in order to understand communication also, in order to understand electromagnetic wave in waveguide, transmission line, optical fiber optics communication, and so we have to understand everything from the differential wave equation. Okay, so that is why I'm going to start first start the wave equation in free space. First wave equation in free space, wave equation in free space, wave equation in free space. So what is the wave equation in free space? We have to understand. So in order to tell the derive the wave equation in free space, I am focusing first Maxwell equation. Maxwell equation. What are the Maxwell equation? Number one, divergence of E equal to minus rho by 3t. 2, divergence of B equal to 0, tini del cross E equal to minus del B by del T, and number 4, del cross B equal to mu J plus mu del D by del T. These are the 4 Maxwell equation. So Maxwell equation is nothing. First equation is derived from Gauss divergence law, static electrostatic, and it is the first order differential equation, and source term is this term is source, epsilon naught is constant, rho is a source. So this is the first order inhomogeneous differential equation, but this is also this is derived from magnetostatics. It is first order differential equation, and B the homogeneous equation, there is no source term. It does meaning of this equation, magnetic monopole does not exist, but electric monopole exists because right hand side is non-zero. And this equation is derived from Faraday equation, and this is Ampere's modified theorem, and this is the displacement vector term. Okay, this is known as the displacement current density. Okay, but in case of free space, what happened? In free space rho is equal to 0. Number 1. Number 2, if rho is equal J equal to rho V or any VD, and EVD, and E is the surge, N is the density, V is the deep velocity, equal to 0. Okay, and mu equal to mu naught, epsilon tends to epsilon naught. This is the parameter. So wave equation in free space, so this term will be 0 and this term will be 0, and another term displacement vector epsilon naught E. So you can write mu naught epsilon naught. This is the wave Maxwell equation in free space. Okay. Maxwell equation in free space. Okay. Now in order to derive, you see, in order to derive wave equation means it is the relation between in order to derive the wave equation in terms of electric field, in terms of magnetic field, you can take any one of these 4 equations. But here this is there is no, here is electric field, but there is no magnetic field term, and here is a magnetic field, no electric field term. This equation and this equation is more reliable to derive the wave equation, because electric field is there, magnetic field is there, magnetic field is here, electric field is there. This is E. Okay. So now if I take curl of any equation, curl of equation number 3, suppose I take the curl of equation, you can take curl of equation number 4 also, no problem. So it will give del cross E, that is in left hand side, equal to minus del cross del B by del T. Is it okay? Now now you, if you remember, I remove this part of it. I remove this part. If you see in the, this is what the del is a vector, so it is a vector triple polar. Have you seen this vector triple, A cross B cross C? And if you want to see, you can see chapter number 1, David Griffith book, page 18, page 88. Okay, if you see the David Gifford book, page number 18, you will find the vector triple product. Scalar triple product is also there. Scalar triple product means it is a polynomial. So vector triple product formula: B into A dot C, C into A dot B. This is not the, this is the formula. If you expand same way, then you will find del dot E minus del square E equal to, this term will, this term is no relation with delta, so you can take it outside. So this term equal to 0 as per Maxwell equation. So this equation E equal to minus minus cancel. So if you put this value here, this value, if you put it here, then you will get minus mu naught epsilon naught del square E by del D square. So minus minus cancel. So you will find del square E equal to mu naught epsilon naught del square E by del D square. Okay, or I remove this part. Finally, what I am getting, so finally first equation, that is D equal to 1 mu naught epsilon naught del square E by del D square. Similarly, if I take the curl of equation number 4, you will get, I am not going to derive that part, I am simply write mu naught epsilon naught del square B by del D square. It's nothing, just replace E by B. From where we can get, if you take the curl of equation number 4, you will get this equation. These two equations are wave equation in free space. Okay. Now, now simple. This equation means I can generalize this equation like this: del square F equal to 1 by mu naught F naught mu naught epsilon naught del square F by del D square, where F equal to E and B. I generalize this equation. Okay. Now mechanical wave equation, classical wave equation. If you see the classical equation, you will find del square F equal to 1 by V square del square F by del D square. This is the classical wave equation. If we compare this, okay, you no need to remember, it's just equation number A1. This is equation number A2. This is a classical wave equation. So if you compare equation number 1 and equation number 2, then V equal to 1 by mu naught epsilon naught under root of is, this is equal to, represent equal to C. This is velocity of light. In velocity of light 2.97982 into 10 to the power 8 meter per second. Okay, this is the velocity of light. Now problem is that because this is V square, there will be two possible solutions. Okay, two possible solution means solution of the wave equation, general solution of the wave equation. Suppose if I generalize this equation, simply generalize this equation like that. Of course, F equal to and 1 by C square, so del square F by dt square. Don't confuse, F means it may be E, it may be B. Okay, the general solution, so I will take F is equal to Kx minus Bt, suppose one solution, and F Kx minus, this is 100 Bt, and F equal to, this is 1 to T equal to, this is third solution. Suppose third solution is equal to F1 Kx minus Bt plus F2 Kx plus Bt. This is also solution. This represents electromagnetic wave. Suppose this is a source of electromagnetic wave propagating along x-axis. Okay, this means electromagnetic wave. This means this is a source electromagnetic propagating along this axis, F2. This is F1. Okay, and third one, suppose this is source electromagnetic wave propagating along this section and this direction, it is represented by Ft. Okay. Now, now this is the basic things. Now our requirement is that the solution of the wave equation. What is the solution of the wave equation? Now solution of the wave equation. What type of solution? Etc. Solution of the wave equation always in phasor form, E naught e to the power I k dot r minus omega t. This is in phasor. Similarly, B equal to B naught e to the power I k dot r minus omega t. This is a three-dimensional solution. Okay, why it is three-dimensional? Why it is three-dimensional is that this is a three-dimensional solution because k equal to kxi plus kyz plus kz k. This is similarly r equal to xi yj plus zk. This is a three-dimensional solution and it is a phasor forms. And what does the meaning of solution? Because any differential equation, if you solve any differential equation, you will get a, if we plot the wave function, if you plot the wave function solution of any differential equation, you will get a curve. Okay. Similarly, is if you see in quantum mechanics, quantum mechanics will always encounter differential equation. This is the Schrödinger equation. E minus V phi. Okay, this is the second order Schrödinger differential equation. Okay, our aim is to find the solution of the wave equation. Suppose if I get the solution of the wave equation a to the power I k x minus omega t. So according to quantum mechanics, according to postulate of quantum mechanics, any quantum mechanical system, suppose one it has a car or maybe one electron, is represented by the wave function. Okay, and second step we have to find the wave function. Once we know the wave function, once we derive the wave function, this is the wave function, this derived from Schrödinger equation, then behavior or nature of the particle or system of particle can be characterized by the wave function. If we analyze this wave function, we can get all necessary information about the behavior of the particle or system of particle associated with this wave function. Similarly, in electromagnetic wave, if we analyze the solution of this first second order differential equation both in position coordinate and time coordinate, so these are the solution. If we analyze this solution, we can characterize the behavior of the electromagnetic wave in particular medium. So what if we find the electric field, if we find the magnetic field, if we energy associated with the electromagnetic in terms of electric field and magnetic field, if we calculate, then we can easily characterize the behavior of electromagnetic wave. That is why understanding of solution is very, very essential. Okay, this is three-dimensional solution. Two-dimensional solution, if I write a two-dimensional solution, okay, I can write this is in two-dimensional solution, I can expand like this: kx x plus ky y plus k. This is y minus omega t. Similarly, b equal to b naught. This part remains same. Okay. Why this two-dimensional solution? K equal to kx k equal to kx I vector, ky j vector, and r equal to xi plus yj. If you take the dot product, then you will find this. This is two-dimensional solution. And one-dimensional solution, simply we write one-dimensional solution. E naught e to the power, suppose along k axis omega t. B equal to b naught e to the power I kx minus omega t. Now you try to interpret it. This is, first of all, this is the phasor solution. Phasor means, suppose Bragg-Hussein criteria, oscillator Bragg-Hussein criteria, product of open loop gain and feedback gain equal to 1. This is a Bragg-Hussein criteria in electronics. Okay, but if I write in phasor form, I can write e to the power alpha. Is it okay? This is the criteria of oscillator, and this is the criteria of oscillator. And phi value, for what value? It is either 0. If phi value is 0, then it will be 1. And if it is pi twice pi, then cos twice pi plus I sin pi. It will be twice pi means 360 degree. Okay, this is the possible angle. Or you can see, if you cos e to the power I phi, if I take the modulus cos phi plus I sin phi equal to 1. Is it okay? That means phasor is a mathematical simplified function. Okay, it does not have physical meaning. Only for mathematical simplicity we often use in the phasor form. But whenever we do calculation, or if we derive any parameter using this function, we always consider the either cos term or sin term. Cos term means this is if you see this equation, then d naught equal to cos x cos kx minus omega t plus I sin kx. Suppose if you want to do calculation, you take this part only, or you can take b naught sin kx only. If you take cos part, then your result, and if you take sin part, then in that case also result will be same. Only there is a difference of phase in between sin and cos 90 degree. Okay, this is the phasor. This is the trigonometric function. This is the phasor form. You can express in terms of. Okay. Now relation between we have already seen that there's a three possible term, and the relations between electric field, magnetic field, and propagation vector. These are the three important terms in electromagnetic wave. Okay. Three possible terms in electromagnetic wave: electric field, magnetic field, and propagation vector. Electric field, it will be, these are the already vector. K is also vector, propagation vector. It will give the information about the direction of propagation of electromagnetic wave, as well as wavelength associated with the wave vector, electromagnetic wave. Now my aim is here, so what is the relation between electric field, magnetic field, and propagation direction? Okay. I have to establish this relation. Before that, I want to give you important point one. See, I want to give you short tricks how to remember the formula, because we don't know we cannot remember all the mathematical formula and terms. So that's why I am giving you short term. See, once you know, see, divergence of E equal to, if I take one-dimensional solution, suppose one-dimensional solution E equal to E naught e to the power I k x minus omega. This is the electromagnetic wave, electric field of wave equation solution, one dimension. And what is the value of divergence of E equal to dE by dx? Is it okay? Then divergence of E equal to, if I take the derivative, then what happens? E naught e to the power I kx minus omega t d by dx I kx minus omega. Is it okay? Then it will be k, I k will come out. It will be e, this whole term will become e, and I k. Is it okay? Now if I cancel e, so divergence equal to I k. Is it okay? Short term. So no need to do anything. Divergence is always replaced by I imaginary number into k vector. Similarly, if I del equal to, I have already find out I k. This is a short term. How to reduce your time in exam. So similarly, if I take the del E by del t equal to how much? If you take the derivative with respect to time, a whole term will come out E naught I kx minus omega t. Okay, then minus I omega. Is it okay? And this is become E into minus I omega. So so first important relations, important point one, that is del is always equal to I k. Remember, once I find del, I will replace del equal to I k. Similarly, if I take the del t, see, again I am telling you del E by del t. Del E by del t equal to E naught e to the power I kx minus omega t minus I omega. So this part will become the E into minus I omega. So E cancel. So del t equal to minus I omega. Okay. So del t equal to, I will directly put minus I omega. Or if it is minus, or if we replace minus I k, then del t equal to I omega. Okay. These two important is really important point to number one. Okay. Now second time I am going to find the relation one. Relations one. First relation I am find out. So from the Maxwell equation, diversion of E equal to 0. See, del equal to Ik into E equal to 0. Is it okay? That means K is perpendicular to E. Is it okay? Similarly, second equation, if I look back the second equation, diversion of B equal to 0. Then this means Ik into E equal to 0, B equal to 0. That means K is perpendicular to B. Okay, from this equation we can conclude that K is perpendicular to E, perpendicular to B. What from relation 1 I can understand that in electromagnetic wave three possible variables, that electric field, magnetic field and propagation the vector, all are mutually perpendicular to x, perpendicular to each other, like Cartesian coordinate system x, y, z. Okay, that is relation number 1. Relation number 2. Relation 2. What is the relation 2? Is suppose I want to find out the relation between electric field, propagation vector and the magnetic field. So you can take any equation. I will take